Tunnels, they're everywhere. Hidden beneath our feet, carved through mountains, and even stretching beneath the sea, tunnels are the silent workhorses of modern civilization. Most of us pass through them without a second thought, but these underground passages are nothing short of engineering marvels. Under cities, through mountains, even under the sea, tunnels connect places that would otherwise be separated by impossible barriers. They allow us to travel beneath rivers, through solid rock, and under bustling city streets, all while life continues undisturbed above. We build them because we have places to be. Fast. In a world where time is precious, tunnels offer a direct route, cutting through obstacles that would slow us down. Whether it's a commuter racing to work or a freight train hauling goods across continents, tunnels make the journey possible. We want to get from point A to point B, and sometimes the quickest way is straight through. Tunnels are the ultimate shortcut, slicing through the landscape and making the world feel just a little bit smaller. These concrete and steel veins keep the world moving. No traffic lights, no roundabouts, just pure, uninterrupted speed. Inside a tunnel, the chaos of the surface world fades away, replaced by a steady flow of movement and light. It's a world designed for efficiency, where every second counts. Across the globe, there are thousands of tunnels, some stretching for miles, others just a few hundred meters. Each one is a testament to human ingenuity, overcoming nature's obstacles with determination and creativity. Imagine a world without tunnels. Picture the chaos if every river, mountain, or city block had to be navigated above ground. The world would grind to a halt, choked by its own geography. London would be a car park. The city's ancient streets, already crowded, would become impassable. Commuters would spend hours stuck in traffic, and the city's famous underground would be just a dream. The Alps, an insurmountable barrier. Without tunnels, crossing these mountains would be a perilous, time-consuming ordeal. Trade and travel between countries would slow to a crawl, and entire regions would remain isolated. We'd still be sailing around the English Channel, complaining about the food and the French. The Channel Tunnel, a feat of modern engineering, has turned what was once a long, uncertain journey into a quick and reliable trip beneath the waves. Tunnels are more than just shortcuts. They're essential for trade, travel, and honestly, keeping the world connected. Every day, millions of people and tons of goods move through these underground arteries, supporting economies and linking communities. Building tunnels has always been a challenge. From the earliest days of hand-dug passages to today's massive tunnel-boring machines, each project pushes the limits of what's possible. The risks are high, but the rewards are even greater. But there's a catch, a big one. For all their benefits, tunnels come with unique dangers that can't be ignored. Tunnels, for all their convenience, present a unique challenge: fire. In these confined spaces, a single spark can turn into a disaster, making safety and preparedness absolutely critical for everyone who travels underground. Fire underground isn't your average bonfire. It's a nightmare scenario that most people never even think about until it happens. Imagine, beneath the city streets, a world of concrete and steel, where the only light comes from flickering bulbs and the hum of traffic above is replaced by an eerie silence. Down here, fire behaves in ways that are both terrifying and unpredictable. It's a whole different beast. Unlike fires in open spaces, an underground blaze is trapped, feeding on anything it can find: cables, plastic, even the very air itself. Firefighters face a unique set of challenges, battling not just the flames but the intense heat, toxic smoke, and the disorienting maze of tunnels. Think about it. You're trapped in a concrete tube, nowhere to go. Temperatures soar to unimaginable levels, sometimes reaching over 1,000 degrees Fahrenheit. Smoke chokes the air, turning every breath into a struggle. The walls themselves radiate heat, and the sound of distant sirens only adds to the panic. In these moments, fear spreads as quickly as the fire itself. Not exactly a recipe for a relaxing commute, is it? The sense of normalcy shatters in an instant. One moment you're heading home after a long day, the next you're plunged into chaos, surrounded by strangers who are just as scared as you are. The problem is simple. Heat has nowhere to go. It builds up, turning the tunnel into an inferno. The confined space acts like an oven, amplifying the temperature and making it nearly impossible for anyone to survive for long. Even the strongest materials begin to fail under such extreme conditions. Then there's the smoke, thick, black, and deadly. It doesn't just sting your eyes, it fills your lungs with toxic chemicals, making every second more dangerous than the last. In a matter of minutes, visibility drops to zero and the air becomes unbreathable. It spreads faster than the fire itself, blinding drivers and choking anyone caught inside. The smoke moves with terrifying speed, pushed along by ventilation systems or the movement of vehicles, making escape routes vanish in a thick, suffocating fog. An escape? Forget about it. In the confusion, people scramble for exits that seem to disappear in the darkness. Doors are hard to find, and panic makes it even harder to think clearly. The very design that keeps tunnels safe from the outside world now becomes a trap. Exits are few and far between, and even if you reach one, good luck finding your way out in the smoky darkness. Emergency signs glow dimly through the haze, but disorientation is common. In these moments, survival depends on quick thinking, luck, and the bravery of first responders who risk everything to save lives underground. So, how do you tame this fiery beast? When a fire breaks out in a tunnel, the situation can escalate in seconds. The confined space means smoke and toxic gases have nowhere to go, quickly filling the tunnel and threatening everyone inside. The key to survival isn't just putting out the flames, it's about managing the air itself. The answer lies in the air, specifically how it moves. Airflow is the silent hero in tunnel safety, especially during emergencies. By controlling the direction and speed of air, engineers can guide smoke away from people and create safer escape routes. Engineers use giant fans, strategically placed throughout the tunnel, to control the flow of air. These fans aren't just randomly installed, they're carefully positioned based on complex airflow models and years of research. Sensors constantly monitor air quality, temperature, and smoke levels, feeding data back to a central control room. It's kind of like creating an invisible wind tunnel that pushes smoke away from fleeing motorists. The system is designed to keep escape routes clear, buying precious time for people to get to safety. In some tunnels, the airflow can even be reversed or redirected in real time, depending on where the fire is and how it's spreading. These aren't your average desk fans. We're talking massive turbines capable of shifting huge volumes of air, sometimes thousands of cubic meters every minute. When seconds count, these machines can make the difference between life and death. In the event of a fire, these fans kick into overdrive, sucking out smoke and pumping in fresh air. The system is automated but can also be controlled manually by engineers and emergency responders, who work together to adapt to the situation as it unfolds. It's a constant battle against nature's fury, and the engineers are armed with some serious wind power. Every second, they're making decisions that could save lives, using technology and teamwork to keep the air moving and the tunnel safe. In the world of tunnel safety, ventilation isn't just a feature. It's the lifeline that keeps hope alive when disaster strikes. But airflow is only half the battle. What about the tunnel itself? You can't exactly douse a concrete inferno with a garden hose. That's where clever engineering and fire-resistant materials come into play. We're talking about concrete reinforced with steel fibers, special coatings that withstand extreme heat, and even fireproof paint. It's about building a structure that can withstand the flames long enough for people to escape and for emergency services to do their job. Think of it like giving the tunnel a suit of armor ready to face the fiery dragon. Sadly, not all tunnels are created equal. The 1999 Mont Blanc tunnel fire, a tragedy that claimed 39 lives, serves as a stark reminder of what happens when safety measures fail. A truck carrying flammable cargo caught fire, quickly engulfing the tunnel in flames and smoke. The fire suppression systems were inadequate, communication broke down, and the result was a catastrophic loss of life. It was a wake-up call for the industry, a brutal lesson in the importance of getting it right every single time. The Mont Blanc disaster wasn't in vain. It really forced a rethink of tunnel safety standards worldwide. Engineers learned from the mistakes, studying the inferno and implementing new, stricter safety regulations. Automatic fire detection systems, more powerful ventilation, better emergency exits, and constant monitoring became the norm. It was about learning from the worst-case scenario and making sure it never happened again. The legacy of Mont Blanc lives on, not in flames, but in the enhanced safety of tunnels built today. Now, not all tunnels are created equal. Road tunnels, with their constant stream of petrol-powered vehicles, present a different challenge than their rail-bound counterparts. Trains, generally speaking, are less flammable. They also run on electricity or diesel, which are less volatile than your average family saloon full of petrol. But that doesn't mean train tunnels can skimp on safety. They still have their own unique challenges: longer evacuation routes, potential for overhead electrical fires, and the sheer number of passengers involved. Whether it's cars or carriages, safety remains paramount. Next time you're speeding through a tunnel, take a moment to appreciate the unseen army working tirelessly to keep you safe. They're not wearing high-vis jackets, but their presence is felt in every meter of concrete and every breath of fresh air. From the engineers who designed the ventilation system to the technicians monitoring the control panels, these unsung heroes are the silent guardians of our underground journeys. They toil away, ensuring that your commute remains quick, efficient, and most importantly, safe. Tunnels are a testament to human ingenuity, a way of conquering nature's obstacles and keeping the world moving. But as we burrow further underground, building longer, deeper, and more complex tunnels, the challenges of fire safety will only become greater. But I, for one, am confident that the ingenuity of engineers will continue to outpace the ferocity of fire. Through constant innovation, rigorous testing, and a steadfast commitment to safety, we can ensure that our underground journeys remain marvelous